All right, so this is page 241. We're talking about dividing polynomials. We just went through adding, subtracting, and multiplying. And so they keep dividing as its own little category because there's a little bit of things, a couple different ways to do dividing. So, the vocab up there, synthetic division, we'll get to that. That's a method, a special method that we can use. And so right here, they're giving you a very specific situation. Okay, so this is what this is saying, if you're dividing by a monomial only, this is only true for a monomial, then you can break the fraction up. Okay, so this is like going in reverse from, if we were here, we would get a common denominator, or since we have common denominators, we could add the numerators. And so like normally you're used to going from here to here. Okay, but what they're saying is like, okay, if you have a monomial, then you can break this up into multiple fractions and then just simplify as you go. So 6 divided by 3 is 2, x squared over x is x, and then 15x divided by 3x would be 5. And so you can divide that way, okay, if and only if you're dividing by a monomial. And so then, right, as they go on, they talk about, okay, so if it's a polynomial, so as long as there's more than one term, you can do something that is very similar to long division of real numbers. And so I'm going to go through an old school long division problem. And then we'll kind of look at like what they're saying down here with the key concept situation. So let's just remember how we go through long division. So let's do something really easy. So 3 going into 7, 5, 8, 9, let's say. Okay, so here's the process if you forget. You go through the very first digit. So you're saying, looking at 7, how many times does 3 go into 7? Okay, and so then you say, okay, well, that's 2. And now you end up multiplying. So 2 times 3 is 6. And now we subtract, and this is very important that you subtract here. So then 7 minus 6 is 1. We bring down the 5, or the next digit, 5 in this case, and now we restart. How many times does 3 go into 15? Well, it goes in 5 times. Notice where I'm writing these. And now we multiply. 5 times 3 is 15. Again, we're subtracting here, 0. We bring down the next digit, 8. So how many times does 3 go into 8? 2. 2 times 3 is 6. Again, we're subtracting 2. Just a point, when you subtract, this number always needs to be smaller than this, or you didn't go into it enough times. Now we're bringing down the 9 for 29. How many times does 3 go into 29? That would be 9 times. And so you got to finish it off. 9 times 3 is 27. And then again, we're subtracting again, so we get 2. So then the question is what do you do with the 2? So there was a couple different things that you guys did. Sometimes you ended up setting up a decimal and adding zeros and seeing how far you could go. Okay? We're not going to think of it that way. The other thing that you could do is say, well, this is the remainder. So like you could say, oh, it's 2,529 with a remainder of 2. Okay, so we're kind of thinking of that, but we're not going to like leave it as a remainder. What we're going to do is say, really, this is 2,529 and 2/3. Okay, so then the 2 is what's left over on the last step, and the 3 comes from what you're dividing by. Okay, so we're going to use the same idea here in a couple of minutes. All right, so then here's the words, and like this can get kind of tough, but if f and x are two polynomials, okay, not monomials, and g of x doesn't equal 0 because we're going to divide by g, we're not allowed dividing by 0, and the degree of g is less than the degree of f, okay, so the denominator needs to have a smaller degree than the numerator. Then there exists a unique quotient q, so that's our answer that we're going to get, and a unique remainder, just like we did a second ago, such that this situation is going on. Okay, so this situation is, right, and this is kind of confusing. So then the answer to your division problem times what you were dividing by plus the remainder better give you the other polynomial. And it's kind of a weird way to look at it. Okay, so they try to like rewrite it out. So again, this is the way it looks. We're dividing f by g. We get some answer, q, and like if you're thinking about what I just did, our q would be 2,529. Okay, and then what they're saying is it's kind of like, oh, they just cross multiplied here. G times q has to equal f, and that's what they're doing here. Okay, so this would be if it goes in evenly, not like the one we just did, right? We didn't go in evenly. We had a remainder of 2. All right, so then they're saying, okay, let's say that you divide f and g, and this time it doesn't go in evenly. We still have this q, in our case is the 2,529, and now we have a remainder. Okay, so our remainder goes back over what we were dividing by, just like it did over here. The remainder was 2, we were dividing by 3. Okay, and so then when we cross multiply, there's the g times the q, right? F equals g times q, and then we had to distribute it here. The g's would cancel. It'd be g r over g. The g's cancel and left with r. Okay, so now they're just saying, okay, well, here's an example, right? We're doing a polynomial divided by another polynomial. It is important that the denominator's degree is less. Okay, so they're saying, if we divide these out, they're basically giving us the answer here. They're trying to show you what's going on here. So they're saying if we divide this one by this one and we get this answer, then that better mean that if we cross multiply, right, if we multiply x minus 3 over here it is, and we FOIL this, we better get what we were dividing into. And sure enough, we do. Okay, and so then the other example here, right? And so what they're saying is this divides into this. This is the answer. So we're going to talk about how to get the answer on the next page. But if this is true, if this statement is true, if we cross multiply by x plus 1, we better get x squared minus 4x minus 1. Okay, so then we multiply, we distribute the x plus 1 to the x minus 5. Again, this x plus 1 gets canceled by this x plus 1. We have a 4. FOIL, combine like terms, sure enough, we get it. And so again, all they're doing is going through like what these statements are saying. All right, so let's take a look at some of the examples. We're going to start off here with a monomial. We're dividing by a monomial. Okay, and that's what this, we kind of briefly talked about like what a negative exponent does. So if it's a negative exponent up top, that means it drops down into the denominator and has a positive exponent. And so since we are dividing this polynomial by this monomial, we can go and break this into 3 fractions. So this is going to be the numerator of the first one divided by this, divided by what's down there. This is the numerator of the second one, numerator of the third one. They're all getting individually divided by 6ab. Okay, so they kind of go through it fairly dramatically, like, right, 24 over 6. Okay, and so then they're saying, okay, if we're dividing by like bases, we subtract the exponents, 4 minus 1, right? Dividing like bases, subtract the exponents, 3 minus 1. And so then that one is going to be 24 divided by 6 is 4, a to the third, b to the second. Okay, they did the same thing here. 18 divided by 6 is 3. A squared divided by a, 2 minus 1 is just a. B squared divided by b, 2 minus 1 again. There's your b. Okay, and so then the same thing here. Right, 30 divided by 6, negative 30 divided by 6, I guess is negative 5. The a, right, when you have 1 minus 1, that's a to the 0, so it's gone. It just cancels out. And then b cubed divided by b, b squared. All right, so let's take a look at the check. Right, I'm going to set this up the way you really want to look at it. So then it's going to be 9x to the 9th y to the fifth plus 21x to the fourth y to the fourth minus 12x cubed y squared all over 3x squared y squared. Okay, so ideally you try this on your own if you want to pause the video, good. But I'm going to just keep rolling here. So we're going to break this up into 3 fractions, right? The denominator is going to stay the same in all of those fractions. So it's going to be 9x to the 9th, y to the 5th, over 3x squared y squared, plus 21x to the 4th, y to the 4th, over 3x squared y squared, minus 12x cubed y squared over 3x squared y squared. Okay, so now we're just doing individual problems, right? This is basically exponent rules. So this first one, 9 divided by 3 is just 3. X to the 9th divided by x to the 2nd, we're subtracting 9 and 2 to get x to the 7th. Y to the 5th divided by y squared, 5 minus 2, y to the 3rd. Plus 21 divided by 3 is 7, right? X to the 4th over x squared, 4 minus 2, x squared. Y to the 4th divided by y squared, 4 minus 2 again, y squared. On to the last one. 12 divided by 3 is 4. X cubed divided by x squared. 3 minus 2 is 1, so just x. Y squared divided by y squared, right? 2 minus 2 is 0, or you can think of anything divided by itself as just 1. And so this is the final answer. Okay, so now we're going to look at dividing a polynomial by a binomial. All right, so here is the process when you do, this is long division basically. We're going to write, notice that we are not dealing with a monomial anymore. Also notice that the degree of this one is less than this one, so we are allowed to divide this out. This could be written as a fraction instead. But the point is what you're dividing by goes on the outside, what you're dividing into goes on the inside. The process is exactly the same. You just got to ask yourself the right questions. So then what you're looking at is only this first term. Don't pay attention to the 4. That'll take care of itself. So you only look at, in this case, the x, the first term, and how many times it goes into the first term here. Now, I don't like where they wrote these. They should be over here, in my opinion, but that's okay. So then what you're saying is what times x gives you x squared? Then it's x. And now you do the multiplication step, just like we did a couple minutes ago. So x times x is x squared. X times 4 is 4x. Now this is the part that you got to watch out for because we are subtracting. X squared minus x squared is gone. That better happen. But now we are doing negative 5 minus 4, and so that should be negative 9x. So you do got to be careful. We bring down the negative 36, and then we start the process over. Again, we're only worried about the first term and the first term. What times x gives you negative 9x? Well, that would be negative 9. Okay, so then once you do that, now you multiply. Negative 9 times x, negative 9x. Negative 9 times 4, negative 36. We are subtracting. Some people like to change their signs. That might be a good idea. But basically, negative 9x minus a negative 9x is 0. Negative 36 minus a negative 36 is also 0. So we have no remainder. So then the quotient, again, the answer, is just x minus 9. And the remainder in this case is 0. And so I would get in the habit of doing 0 over whatever you're dividing by. So this is a good answer also. Okay. So let's take a look at the check. So again, it satisfies the requirements of the degree and the denominator being lower. So then we can set it up like this. I'm taking the denominator, writing x minus 8, and then I'm going into x squared plus 6x minus 112. All right. So now we're starting the process of division. We're only worried about the first term. So what times x gives you x squared? That would be an x. Now we multiply. X times x is x squared. X times -8 is -8x. Now we're subtracting. X squared minus x squared is gone. 6 minus a -8 is positive 14x. We bring down the -112. And now this process restarts. What times x gives you 14x? Well, that should be 14. So a positive 14. Now we're multiplying. 14 times x, 14x. 14 times -8, it would be minus 112. We're subtracting again. 14x minus 14x is 0. -112 minus a -112 is also 0. So then our remainder is 0. And so then we're going to write it as x plus 14. And we don't need to write the remainder there. All right, moving on to the next example. Everything is the same, okay? We still get the requirements we need, and we still set it up the same way. What we're dividing by is on the outside. What we're dividing into is on the inside, okay? Make sure these are in order, by the way, or otherwise it might throw you off. But again, all we're doing, right, just looking at the first term, what times z gives you 3z cubed? Well, that'd be 3z squared. So now we multiply. 3z squared times z, 3z cubed. 3z squared times -5, -15z squared. Now we're subtracting. Again, watch your steps here, watch your signs. 3z cubed minus 3z cubed is 0. -14z squared minus a -15z squared is 1z squared. Bring down the -z. Now we restart. What times z gives you z squared? That'd be a positive z. Now we multiply. Z times z, z squared. Z times -5, -5z. Z squared minus z squared is 0. -7z minus a -5z, again be careful, -2z, and now we bring down the 3. And we're two more steps, right? But again, same process. What times z gives you -2z? That would be -2. -2 times z, -2z. -2 times -5, positive 10. And now we're subtracting. -2z minus a -2z is gone, 0. 3 minus 10 would be -7. Okay, so like, I don't know, they don't really have it all written out, but what you should do with that -7 is, right, so there's our answer up top, but we have this remainder left over. So you're going to say plus -7, or whatever you have left over z minus 5. And that would be your final answer. Okay, so they did finish it off just on the other page. Right, now they, the only difference is they turned it to a negative sign here. Okay, great. Plus a -7 is the same difference. Okay, so let's take a look at this other one. We'll do the check together. I want you guys to feel comfortable with these. Notice how they wrote it, right, using the negative exponent. So this is just going to be what we're dividing by. So then it's going to be x minus 2 on the outside. That's going into -4x cubed plus 5x squared minus 2x minus 9. All right, thank you. All right, so what's happening again is you're just looking at the first term. And what times that first term gives you this first term? Right, so in this case, it should be a -4x squared. Now you're multiplying, right, just like in long division. So -4x squared times x, -4x cubed. -4x squared times -2 is positive 8x squared. All right, remember we are subtracting here. -4x cubed minus -4x cubed is 0. Okay, 5x squared minus 8x squared should be negative 3x squared. All right, now we're bringing down the next step. And now the process starts again. What times x gives you negative 3x squared? So that'd be a negative 3x. And now we're multiplying. Negative 3x times x, negative 3x squared. Negative 3x times negative 2 plus 6x. And now we're subtracting again. So negative 2x minus 6x looks like negative 8x. Bring down the next term, negative 9. Now the process starts over again. X, what times x gives you negative 8x? Be a negative 8. Now you multiply. Negative 8 times x is negative 8x. Negative 8 times negative 2 is plus 16. We're going to subtract again. Negative 8x minus negative 8x minus negative 8x, gone. Negative 9 minus 16 looks to be negative 25. Okay, that's your remainder because we can't multiply anything else, right? Anything else times x wouldn't be a polynomial anymore. To get to negative 25 wouldn't be a polynomial anymore. So I always just write it with a plus, and then whatever it is, negative 25 over what you're dividing by. All right, so moving on to synthetic division. Synthetic division is scary, but it sounds scary, but it's pretty easy. Okay, I'm going to walk through how this works. You should read the steps if you're not sure, but it is very easy, but it is very particular also. With the long division, you can use, right, the denominator can be anything that you want. Okay, all of ours were binomials, but synthetic division can only be done with a binomial in the denominator. Okay, so if you have that situation, then you can do synthetic division. So again, I would read those steps, but I'm just going to walk through what they are. Okay, I don't think that you guys are getting anything except for a variable and then a number. Okay, it's a little bit different if it was like 2x plus 3, but not dramatically different. I don't think you guys are doing that. But whatever you're dividing by, you ignore the x and take the opposite sign of this number, negative 3, right? And they put it in this little half box. And then they pull out only the coefficients of every term. Now you do have to pay attention if they skip one, right? We're going from x cubed to x squared to x to nothing. And so that's nice. We don't have to worry about anything. But you do have to pay attention because if you skip, you got to make sure that gets noted here in this step. But you can see all the coefficients are the only things that we're pulling. So there's the 3, there's the negative 2, there's the negative 53, and then the negative 60. And now the process is very simple because all we're doing is multiplying and adding. I guess adding and then multiplying is a better way to think about it. All right? So once you got it set up, then you add. 3 plus 0 is 3. And now you multiply. Negative 3 times 3 is negative 9. Now you add. Negative 2 plus negative 9, negative 11. Now we multiply. Negative 33 times negative 11, positive 33. Then we add. Negative 53 plus 33 is negative 20. Finally, we multiply. Negative 3 times negative 20 is positive 60. Negative 60 plus 60 is 0. This number here is your remainder, and it does a couple different things for us when we're doing synthetic division. It says continued on the next page because we're not really done yet, but that was the hard part. Okay, so it's kind of hard to remember, but basically what we're doing is we started with something that was an x cubed. These are the coefficients at the bottom after we did the add, multiply, etc. This is what was left over on that bottom line. So it was just a 3, a negative 11, and a negative 20. Then you remember our remainder was 0. And so since the numerator was an x cubed, we just dropped down by 1, and then dropped down 1 every single time. So that means, right, that's dropping down 1 from x cubed is x squared. So there'd be 3x squared minus 11x minus 20. There's no remainder. Okay? So I didn't think they were going to do this, but they do have this situation where we can divide by something other than just like an x minus or x plus something. So it is slightly different. Okay, so synthetic division has to be in a very particular situation. So right, we set it up, we got our numerator, we got our denominator, but again, we don't have a 1x here, we have a 2x in this case. So what you got to do is factor out or divide by whatever that number is. So we're going to divide everything by 2, but we're not allowed to only mess with the denominator. That's not, you're changing values. So we also had to divide the numerator by the same number. That's an equivalent of 1, and so we're allowed to do that. So we divide both of them by 2. And so then 4 divided by 2 is 2, 37 divided by 2 is 37 over 2, 4 divided by 2 is 2, 9 divided by 2 is 9 over 2. Okay, 2x divided by 2 is x, negative 1 divided by 2 is negative 1/2. Okay, so again, now it is the same. And so then they have us a. And so what they're saying is what we're dividing by now is this x minus 1/2. But for synthetic division, we want the opposite sign. So we're going to use positive 1/2. We're dropping that in this little half box. And now we're populating the rest of these with just the coefficients. But notice that we're going from x to the 4th and we skip x cubed. You need to take note of that. Okay, so there is no x cubed in here, but we need to add that here as a 0. So every term needs accounted for. So then we have a 4, oh, sorry. Right, we're down here actually, after we divide by 2. So then it's a 2. It's a 0 because we don't have an x cubed. A negative 37 over 2. A 2 and a 9 over 2. So watch out for a missing term. But the process is the same, right? All we're doing is adding and multiplying now. First step is to add, so it's a 2. Next step is to multiply. 1/2 times 2 is 1. Now we add. 0 and 1 is 1. 1 times 1/2 is 1/2. Now we're adding. Negative 37 over 2 plus 1/2 is negative 36 over 2, which is negative 18. Ask your calculator, it knows. Right, negative 18 times 1/2, right, we're on multiplying again. That's negative 9. Negative 9, we're adding 2 plus negative 9, so that's negative 7. 1/2 times negative 7 is negative 7/2. We're adding 9/2 plus negative 7/2 is 2 over 2 or 1. Okay, so again, this is easier to see on this page. Right, we started with an x to the 4th. So then that means our answers are now x to the 3rd as the first one. So 2x to the 3rd, 1x squared, minus 18x, minus 7. Here's our remainder. We treat it the same way. 1 over, the remainder over what we are dividing by. Okay, now essentially what they're saying is that, to me this isn't like a huge deal, but what they're saying, it's bad form to have a fraction inside of a fraction. Remember where this fraction came from was what we were dividing top and bottom by 2. So now to get rid of it, we're going to multiply top and bottom by 2. Okay, so then it's going to be 2x minus 1. And then we have to multiply this one also by 2 for the 2. Okay, so I assume if you have to answer this, which you will on Friday, you'll have to answer it. Right, they want you to write it like this. All right, so one more for me. I think it's one more. One more? One more for me. Oh, yeah. One more for me. Do that for you guys.
Thank you, Mr. Rose.
You're welcome. For the other unfortunate classes that don't get to hear this recorded, I apologize. And it's not because I like this class more. Don't if you put that on the video, then like I'll have to answer questions. Okay?
Hey, if I go yard to plan, I'll get 5 extra credit points.
That's, I don't know from who. Like maybe some other class.
From you.
I will go, well done, sir.
Well done, sir.
All right, here we go. Enough of that. Just to be clear, this is not in a very sticky situation. The class that is witnessing the video, either live or recorded, is clearly my favorite class. Yeah, did you say I covered all my bases? What?
You said live first, so.
Well, yeah, I mean, it's just a series, but they're equivalent because I used a comma. I didn't rank them.
You said live first.
That's true. I think live comes first in the alphabet, though. The rest of them don't want to hear this conversation. So anyway, here's what we're doing. We're really dividing 4. This is your check. I'm doing your check for you. You guys are used to me doing more homework than you do. So here we go again. All right, again, synthetic division does not work with that 4x. So we have to divide, or more sensually, multiply by 1/4. I'm a pretty sensual guy when it comes to math. All right, so then that makes this x to the 4th. Then that makes this one plus 3/4 x cubed. And then we got minus 3x squared minus 1/4 x plus 6/4. I'm just going to leave it as 6/4 right now. And then x plus 3/4. All right, remember, take the opposite sign. Take the opposite sign. Negative 3/4. Check out for skipped terms. If there's a skipped term, put a 0 in there. Okay, there's not on this one though. All right, so now we're just grabbing coefficients. 1 3/4, negative 3, negative 1/4, and 6/4. You do need to give yourself a little bit of room because you're going to put stuff in there. But now it's just an adding and multiplying, adding and multiplying. Add 1. 1 times negative 3/4 is negative 3/4. Oh, look, it cancels 0 because we're adding. Now we multiply and get another 0. Now we add and get negative 3. Now we multiply again. It's not 0, you're just multiplying and adding. I mean, that's the whole thing. Right? So now we're on multiplying, if you were keeping track. Right? So then that's a positive 9/4. Now we're adding. That's 8/4. 2. Ask your calculator. Make friends with your calculator if you're not sure. Right? Now we're multiplying. That's a negative 6/4. Boom. 0 on the remainder. Right? What we're talking about here is now, right, we start with x to the 4th. Now we're dropping down 1. X to the 3rd. For you, those that are keeping track. Down 1. Yeah. X cubed. Plus 0x squared. So I'm not going to write it. So now we're on to minus 3x plus 2. There's no remainder. There's your answer. Uh-oh, turn on battery saver. 15% remaining. My luck, I'm done. Oh yeah, good luck. I'll see you guys on the next day. We'll do a bunch of synthetic and long division together. It'll be super awesome. Don't forget about your quiz on Friday. Make sure you guys do your spiral reviews. Yeah, that includes you too. Oh, this time, yeah. Always do them.